Hey everyone, and a huge welcome to all the Indian IT students tuning in. So, in this explainer, we're taking a pretty massive leap. We're going to step out of that safe, theoretical bubble of the classroom and jump right into the wild, thrilling reality of actually bringing artificial intelligence into the real world. We're talking about AI in production today. And, more importantly, we'll cover how to make sure all that hard work you put in actually survives out there.
Because let's be real, it's the elephant in the room for literally every data scientist and engineer out there. Why do perfectly trained AI models absolutely crash and burn in the real world? Look, you might have totally aced your machine learning assignments, but I've got to tell you, classroom theory, it definitely doesn't equal automatic production success. The real world is messy, it's totally unpredictable, and it is entirely unforgiving to fragile code.
Okay, let's dive into this. Just look at the stark contrast between these two environments. In development, your data is neat, it's static, and it behaves exactly how you expect it to. It's like a highly controlled laboratory. But production? Oh, production is pure chaos. You're dealing with live data drift, super strict latency constraints, and totally unpredictable edge cases. So, what you really need to wrap your head around is that these two environments demand completely different skill sets. Building a model, that's literally just step one. Engineering it to survive and thrive out there for actual end users is a whole different ballgame.
So, to really unpack this theory versus production reality, we need a solid roadmap.
And to understand this massive gap between the code on your laptop and what actually works for millions of users, I absolutely love this quote from our source material. Deploying AI is like driving a car. Condition, roads, and a map matter. I mean, it perfectly hits the nail on the head. Think about it. You wouldn't just jump into a car and expect to magically teleport to your destination without checking a few critical things first, right? Deploying AI is exactly like driving that car. You've got to prepare for the journey. Let's break that down a bit. First up, the car itself. That represents your trained model. Now, just like you'd make sure a physical car is in tip-top mechanical shape before a huge road trip, you have to ensure your AI model is trained exceptionally well. And hey, this doesn't just mean snagging a high accuracy score in a Jupyter notebook. It means your model needs properly tuned hyperparameters and optimized code way before it ever touches a production server. Because, let's face it, a broken engine won't even get you out of the driveway, and a poorly optimized model, it's going to stall out the second it hits a live environment. Next up, the road. In our little analogy here, a nice, clear, open road represents clean data. Because you can have the fastest, most beautifully engineered sports car on the planet, but if the road is covered in boulders and debris, you're going to crash. In a data context, those boulders are missing values, out-of-bounds inputs, or schemas that just change in real time. For your AI model to work, having robust data pipelines that clean and process high-quality data is an absolute, non-negotiable requirement. Without them, your model just can't function. And finally, we have the map. Having a solid map relates directly to ensuring your infrastructure is fully ready for deployment. You need to know exactly where you're going and have the systems in place to actually support the journey. We're talking about building scalable APIs, using containerization like Docker, and provisioning the right cloud hosting resources. Because without that ready infrastructure to guide, host, and scale your model, your perfectly tuned car on that clean road is just going to end up hopelessly lost.
Okay, so now that we know what makes a successful road trip, let's talk about the absolute worst part, the potholes. These are the disastrous deployment pitfalls that can completely ruin your project. So keep your eyes on the road, because hitting one of these will blow out your tires before you even get started. Our first major pothole is overfitting. This happens when your model basically just memorizes the noise and extreme variance in your training data, rather than picking up on the actual underlying patterns. So, sure, it absolutely aces your development tests because it effectively memorized the answer key, but it fails spectacularly when it's faced with new, unseen production data.
And then, bam, we swerve right into the next major pothole, underfitting. If overfitting is memorizing the textbook word for word without understanding a thing, underfitting is failing to learn the core concepts at all. In this scenario, your model's architecture might just be way too simple. It hasn't captured enough complexity from the data to make any useful predictions whatsoever. Believe me, both overfitting and underfitting are surefire ways to crash your project the very moment it goes live. And that brings us to the final, and frankly, extremely dangerous pothole, data leakage. This is a critical pitfall where your data is not kept clean and strictly separated between training and testing environments. It's literally like peeking at the exam questions before the test. For instance, if your model accidentally uses future data points or target variables during its training phase, it's going to look like an absolute genius in the lab. But it will collapse completely when it goes live, simply because it doesn't actually know how to predict anything organically. Avoiding train test contamination is absolutely key here.
So, with all those hazards out there, how do we actually build a solid framework for successful deployment and avoid those crashes?
Well, we follow an explicit three-step framework, and this brilliantly illustrates the process. Step 1, data preparation. This is paving that clear road with robust pipelines and incredibly clean data. Step 2, model training. That's getting the car in pristine condition, tuning those hyperparameters and actively dodging the overfitting and underfitting traps. In step 3, model deployment. Putting the car on the road with the right infrastructure map. But here's the kicker. This final step requires continuous monitoring, because data drifts and real-world conditions constantly change. Executing and moderating these steps rigorously, that's the real secret sauce to production AI.
Let's take this framework out of the abstract for a second and look at some real-world examples.
Think about a customer service chatbot. This is an AI model that absolutely must deeply understand the weird nuances of human language to keep a conversation running smoothly. If it isn't trained well, like say it hits that overfitting pothole we talked about, it will strictly expect the textbook grammar it was trained on. So the second a real actual user types something with a bit of slang or a couple of typos, the chatbot just completely fails to understand them and the whole conversation breaks down instantly. Not a great user experience, right?
Or consider a recommendation system. A finely tuned model is going to correctly recommend products to a user based on their past purchases, which totally drives engagement. But if the model isn't trained well, or if it's being fed stale, poorly processed historical data, it's going to start recommending completely wrong products. And the immediate result of that? Lost revenue and a very unhappy user. This directly proves exactly why properly managing your data pipelines and infrastructure is just absolutely vital to your actual business outcomes.
So, the crucial point is, how do you take all of this and actually apply it as best practices?
Especially for all the IT students listening who are super eager to bridge that massive gap between development theory and production reality, here is your action plan. First, you've got to get totally comfortable with cloud platforms like AWS or Azure to really master real-world infrastructure and mapping. Second, start leveraging open-source tools. Frameworks like MLflow or Kubernetes, they are the industry standards for deployment and scaling. And third, if you want to make your models highly relevant locally, practice using data from Indian open data portals so you can truly understand regional data nuances. Seriously, doing these three things will give you a massive head start.
All right, so we've checked the condition of the car, we've paved the road with clean data pipelines, and we've plotted out the route on our infrastructure map. And you know exactly which potholes to avoid. The only question left is, you have the map and the keys, so what will you drive into production first? It's time to stop just training models in a little sandbox and start building real solutions for the real world. Thanks for joining me for this explainer. Now get out there and build something incredible.